Let us discuss few important questions from previous year's papers. This is a transition table given in the question. So from this, we need to take this first row as it is in the DFA transition table. And now, in order to get the next state, we need to pick this one. Pick the state Q0, Q1 and take it as the new state. Now, we need to find out transition function for this. It can be written as delta of Q0 on A union delta of Q1 on A. So what is delta of Q0 on A according to this NFA transition table? Q0 on A is Q0 Q1. So write Q0 Q1 and Q1 on A is Q1. So here it should be Q1. So if you take union of both, we'll get Q0 Q1. So that should be represented in the table here. So we got delta of Q0 Q1 as Q0 Q1 on A as Q0 Q1 only. Now we need to solve this B part. So just like how we did the first one, you need to do the same for second also. So take Q0 Q1 on B equal to, this can be written as delta of Q0 on B union delta of Q1 on B. So Q0 on B, check the NFA table. Here Q0 on B is Q2, right? And Q1 on B is Q0. So write both of them. So if you take union, you'll get Q0 Q2. So that should be written corresponding to Q0 Q1 on B. Now you need to check if you got any new state. So already Q0 is over and here Q0 Q1 over. But this Q2 is also a new state. So we need to solve that also. So next row will start with Q2. Even though we got this new state, as we are having new state in the first row, we need to solve that. So we need to find out Q2 on A. So this can be written as delta of Q2 on A and find it from the transition table. We got Q0. Then Q2 on B is Q1, Q2. So write it as it is. So here you can write Q2 as Q0, Q1, Q2. Now you need to check if we got any new state other than the ones present in the first row. Yes, we got. So we got this as this is a new state only, right? Now we need to find out transition of Q0, Q2. So take this can be written as Q0, Q2 on A, which is delta of Q0 on A union delta of Q2 on A. So what is delta of Q0 on A? According to NFA table, it is Q0 Q1. So write Q0 Q1 and delta of Q2 on A. So Q2 on A is Q0. So here it is Q0. So union of those two is Q0 Q1. So in the DFA table corresponding to this place, we need to place Q0 Q1. So Q0 Q2 on A gives you Q0 Q1. Then delta of Q0 Q2 on B can be written as delta of Q0 on B union delta of Q2 on B. So go to NFA table. Delta of Q0 on B is Q2. So here it is Q2 and delta of Q2 on B. Q2 on B is Q1 Q2. So we'll get Q1 Q2. So replace this here. So Q0 Q2 on B is Q1 Q2. Now check if we got any new state. So we solved this Q0 Q1, Q2 and this Q0 Q2 also over. So here in this place we got one new state that is Q1 Q2. So find out transition of Q1 Q2. So delta of Q1 Q2 on A can be written as delta of Q1 on A union Q2 on A. So Q1 on A means it is Q1. Q2 on A is Q0. So union will be Q0 Q1. So write it here Q0 Q1 and then delta of Q1 Q2 on B. So Q1, Q2 on B can be written as Q1 on B union Q2 on B. Q1 on B is Q naught. Q2 on B is Q1, Q2. So here again we got one new state, that is Q naught, Q1, Q2. So we need to find out transition function for that. So write it here, Q naught, Q1, Q2. Now again you need to find it on A as well as B. So Q naught, Q1, Q2 on A can be written as Q naught on A union, Q1 on A union, Q2 on A. So this is nothing but Q naught on A is Q naught, Q1. Q1 on A is Q1. Then Q2 on A, it is Q naught. So we got Q naught, Q1. In the same way, we need to do for B also. Now you need to place these two values in the transition table. So here you need to write A and B values. Now check if we are left with any new state. So there are no new states, we solved everything. So we can stop this process here. So here what is the initial state? Q naught, and final states are Q2, Q naught, Q2, Q1, Q2, Q naught, Q1, Q2. This is the transition diagram according to the transition table we got here. Here Q naught on A is Q naught, Q1. So Q naught on A is Q naught, Q1. Q naught on B is Q2. Next, Q naught, Q1 on A is Q naught, Q1. So write it as self loop. Q naught, Q1 on B is Q naught, Q2. And here Q2 on A is Q naught, Q2 on B is Q1, Q2. So Q2 on A is Q naught, Q2 on B is Q1, Q2. Q1, Q2 on A is Q naught, Q1, Q1, Q2 on B is Q1, Q2. Q1, Q2 on A is Q naught, Q1, Q1, Q2 on B is Q naught, Q1, Q2. And Q naught, Q2 on A is Q naught, Q1, Q naught, Q2 on B is Q1, Q2. Then finally, Q naught, Q1, Q2 on A, it is Q naught, Q1. Q1, Q2 on B is the same state. So you need to write it as self loop. So this is the final transition diagram for the obtained DFA. Now, so this first part was done. Find the language accepted by DFA and validate a string using transition function. So these are the 5 final states. Set of strings accepted by state Q2 are, here you can see it will accept B, then B, A, B, next B, A, B, A, B, and so on. So it was written like this. So here Q2 is a final state. So from initial state, all the strings which are starting with B as well as ending with B are considered as strings that are accepted by this Q2. So language can be written as set of all strings starting and ending with B on input symbols A comma B. Then if you take this Q naught Q1, so check this diagram. Q naught Q1, it has self loop. So it will accept all possible combinations of yes. So language is set of strings containing A power M where M greater than or equal to 1. Next is Q0, Q2. So here you can see this is Q0, Q2. So the strings which are accepted by this are, so if you start from Q0, automata moves from Q0 to Q0, Q1 and from here to Q0, Q2. So you can have string as A, B. Okay. So this is A, B, or else A, B, and here you have one more path, A and then B. So that is B, or it can even have A, B only, and so on. So this can be written as set of strings that ends with B. So here string should end with B. Then fourth state is Q1, Q2. So if you start from Q0, Q0 on A, Q0, Q1, then there is no direct path to this place, this state. So Q0, Q1 on B, Q0, Q2, Q0, Q2 on B, Q0, Q1, Q2. So you'll get A, B, B. So that is minimum string. And after this, you can have A, B, B, A, B, B. So what is that? A, B, A, B, and then B. That is your second one. Next, and if you move in this direction, it is even possible to get B, B. So that is the third possible string starting with B. Or you can even have B, A, B, B. And so on. So these are some possible strings. So this can be written as set of strings that ends with BB. For Q0, Q1, Q2, strings are A, B, B, B. Okay, that is one possible string. Then A, B, 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 and here self loop. So you'll get A followed by 4 B's and so on. So this can be written as set of strings ends with BBB. So you can see minimum string is A followed by 3 B's. So that is the second part. So the language accepted by DFA. Now you need to validate string using extended transition function. So this is the formula or notation. So if you take B, so you can take any string. Here from this language, I'm taking the string B. So this can be written as, you need to start with the initial state. So here, this is the input string which we are taking. So this is Q0. So Q0 on first input symbol B. You need to find that. So Q0 on input symbol B is Q2. Then take two strings Q0 BA. So Q0 BA is can be written as Q0 on B comma A. So what is Q0 on B? Q2, and write this symbol as it is Q2 on A. So delta of Q2 on A is Q0. So that you will get it from the transition table. Q2 on A is Q0. Then take next three strings or next three characters Q0 on BAB. So this can be written as delta star of Q0 on BA comma B. So here delta star of Q naught on BA. So this is the value, which is Q naught. So write Q naught, and here the leftover symbol is B. So Q naught on B, from the transition table it is Q2. Then take next character from the string. So we are taking 4 characters now. Q naught on BA equal to, it can be written as Q naught delta star of Q naught comma BAB. Then the last one, that is A. So here we already got delta star of Q naught comma BAB as Q2. So write that Q2 and leftover value is A. So we got Q naught. Now take all the characters from the input string, all 5. So this can be written as delta star of first 4 characters together and last one separately. So we got the value of delta star of Q naught comma BA as Q naught. So write it and B. So from this we got this value as Q2. So this is nothing but final state. So string is reaching final state and we can say that the string is validated. So what is the final state in the diagram? It is Q2. So as this string is reaching the final state, we can say that the string is accepted. Then coming to second question, minimization of following DFA. So this is the given question. And from this first we need to draw transition table like this based on the transition. So A on 0, it is moving to B. A on input symbol 1 goes to F. Then B on input symbol 0 moves to G. B on input symbol 1 moves to C. C on input symbol 0, A. C on input symbol 1, self loop, C. So like that you need to write for all the states. Now step 2 is we need to find out 0 equivalence, which is represented with pi naught. We need to write all non-final states in one set and final state in another set. So here what is the final state? C. You can see this state is represented with double circle. So this is a final state. So write the C in separate set and all non-final states in one set. Now, so that is nothing but pi naught. Now we need to find out one equivalence, that is pi 1. So for that, we need to take a comma b and find out transition function. So find out delta of a on 0 and b on 0. So delta of a on 0 is b and delta of b on 0 is g. Then similarly find out delta of a on 1. A on 1 is f, b on 1 is c. Okay. Now you need to check this. So you need to check whether both b and g are present in the same set or not. So here you can see in pi naught b and g are present in same set. Now you need to check this f and c. So here f is present in one set and c is present in another set. So we can say that this A is not equivalent to B. Say if here also if both of them belong to same set like the previous one, then we can say that A is equivalent to B. But as F and C are not present in same set, this is written as A not equivalent to B. Then you need to check A comma D. So here we need to check like this: A comma B, then A comma D, A comma E, A comma F, A comma G, A comma H. Right? So already A comma B was done. Now you need to check A comma D. So for this also input symbols are 0 and 1. So you need to take A comma 0, D on 0, A on 1, D on 1. So A on 0 from the transition table is B. And so here it is B. then D on 0. D on 0 is C. Now A on 1 is F, D on 1 is G. So write them. Now we need to check whether B and C are present in same set. No, C is represented as a separate set as it is a final state. So as both of them are not equivalent or as both of them are not present in same set, we can say that A is not equivalent to D. Without checking the second set, we can directly write it like this. Now, we need to go with the third one. Third one is A comma E. So again check A on 0, E on 0, A on 1, E on 1. Now you can see B and H are present in same set, whereas F and F, as both of them are identical, no need to check separately. So as all of them are present in the same set, we can say that A is equivalent to E. And fourth one is A on F. So A on F is A on 0 is B, A on 1 is, sorry, F on 0 is C, A on 1 is F on 1 is G. So here C is a final state. As B and C are present in two different sets, we can say that A is not equivalent to F. Now we need to check the next part, that is A on A comma G. So A on 0, G on 0, A on 1, G on 1. So from the transition table, we got the values. Now check if B and G are present in same set. Yes. F and E are present in same set. Yes. So we can say that A is equivalent to G. Then the last one, A comma H. So here A comma H, these are the values. If you see this, B and G are present in same set, fine. But here F and C are not present in same set. So we should write it as A not equivalent to H. So this is one equivalence. So pi 1 is represented as, so you need to find out all the states or all the states which are equivalent and you need to represent them in one set. So here you can see A is not equivalent to B. So you need to write this B in separate set. Then A is not equivalent to D, represent D in separate set. And A not equivalent to F, separate set. A not equivalent to H, separate set. Okay, so we separated some states which are not equivalent to A and placed it in another set. And the values which are, or the states which are equivalent to A are present in the same set. Now C, that is already in a different set. Then we need to find out two equivalents now. So you need to use the same approach. Now we need to do it for A comma E and A comma G. So here A on 0, E on 0, A on 1, E on 1, get the values from transition table. And here B and H present in same set. As both of them are F only, they are present in the same set. So we can say that A is equivalent to E. Now you need to check this A comma G. So here B and G, check them. Here B is present in one set and G is present in different set. So for finding two equivalents, you need to check values in this pi 1 but not in pi naught. Okay, so here in the previous case, B and H both are present in same set, second one. And as F is identical in both the cases, we wrote it as equivalence. We wrote this condition as equivalent. Whereas here B and G, so G is present in first set, B is present in second set. So they are not equivalent. So directly we can write it as A not equivalent to G. Now we need to check this set also. B with D. So B and D, GC, we got GC, CG. So here GC, C is a final state. It is present in separate set. So B is not equivalent to D. Now if you take B comma F, for that also we got GC and CG only. So here also both are present in different sets. So B not equivalent to F. Now you need to check with the last one, B comma H. So B comma H is GGCC. Again, as these two values are identical, we can say in both the cases it is equivalent. So B is equivalent to H. Now we need to write A comma E in one set. Here you can see A comma E is written in one set. G should be separated from this as A is not equal to G. Then B is equivalent to H. So both of them remain in same set. And as B is not equivalent to D and F, you need to separate them from the previous set and write them separately. Now find out three equivalents for this pi 2. So here you need to check A comma E now. So A comma E can be written like this. We got BH and FF. So B and H, they are present in same set. So they are equivalent. So we can say A is equivalent to E. Now you need to check B and H also. So we got GG, CC. Again, both are identical. GG is identical, CC identical. So we can say that B is equivalent to H. And the third case, F comma D. So we got both CC as well as both GG. So again, we can say that F is equivalent to D. So pi 3, we got pi 3 as the same one which is equivalent to pi 2. So since there is no change here and pi 2 is equivalent to pi 3, we can stop the process at this point. And no need to check the 4 equivalence case. Finally, you can draw the transition diagram for these states. Next question is construct finite automata equivalent to the following regular expression. So this is a given regular expression. We need to apply subset method. So here this can be written as, these are the notations. A plus B can be written like this, A into B and A star. So for this one, if you take, let us take the regular expression and try to break it so that it comes into one of the three scenarios. So if you take 0, 1 into this part, so this is in the form of A into B. Okay, so we can use this notation there. And if you take this one, again, this complete part 1 into 1 0 whole star plus 0 into 1. Again, this can be taken as A and the second part will be taken as B. And if you take the for this complete case, again you can split it into this part as A plus this part as B. This is in the form of A plus B. And if you take this 1 0 star, this is in the form of A star. So you can apply this third rule. So first I'm taking 1 0 star and the notation we use here is the third one. So as we are having two input symbols, you need to apply this rule by placing two input symbols in two separate paths. After this, we are multiplying this value with 1. So multiplication means A into B. So already we got this value as B. So you need to take that as it is. Till here, this is similar to the previous one, previous result we got. And what is the notation for A into B? So already we got this B value. Now you need to add A epsilon. So here input is 1. So add 1 epsilon. And then, so this first part was over. 1 into 1 0 whole star. You need to add 0 to that. So let us add 0 for this. This is in the form of A plus B. So what is A? This complete value now it becomes A. So you need to write this complete part in place of A here. Whereas this B part, it remains as it is. You can observe this. Here, this part is written like this. In place of B, we are placing 0. And now this should be multiplied with 1 according to the question. So we are done with this part. So we need to multiply that with 1. So this is in the form of A into B. So this complete part which we got before, that becomes A. You need to, so this till here it is A. Now we need to add this part, that is it becomes B. So this one it is A. We are adding from this place to here, this state to this state. Okay. So this is the notation. So first this part, this complete part was done now. Now you need to multiply this complete part with 0, 1. So take this whole result. So this is the whole result which we got in previous step. Multiply that with 0 and 0, 1. So after doing this, this is the final automata which we got for the given regular expression. And the fourth question is, we need to construct regular expression for DFA using Arden's theorem. So there is a rule here, say if P and Q are two regular expressions, then if you have this R equal to Q plus RP, then you need to replace that with R equal to QP star. So let us take this from the given DFA. First we need to find out equations. So here you need to write the equation by observing the incoming edges. So if you take Q1, so for Q1 there is no incoming edge. It is not receiving input from any other state. So that is empty. As this is the initial state, we need to add epsilon to that. Then if you take Q2, Q2 is receiving input from Q1 and the input is 1. So it should be written as Q1 on 1. At the same time, it is having self loop, so it should be written as Q2 dot 1 and Q3. From Q3 also it is receiving input, so Q3 dot 1. Then moving to Q3. So frame Q3 equation. Q3 on input symbol 0, it is moving to same state Q3. So it can be written as Q3 dot 0 and it is receiving input symbol from Q2. So Q2 dot 0 and it is receiving input from Q1 also. So that is written as Q1 dot 0. Okay. So then you need to check the final state after framing the equations. So here in the diagram, Q3 is the final state. So we need to solve this Q3 equation. But for solving Q3, if you observe this, we need Q1 as well as Q2 also. Okay. So Q1 is epsilon. So we don't have any issue with that. But we need Q2. So first we need to solve Q2. So solve this Q2. So wherever we have Q1, you need to replace that Q1 with epsilon. So this can be written as Q2 dot 1 plus epsilon dot 1 is 1 only and Q3 on 1. This can be written as 1 plus Q3 1 in plus Q2 1. So this is in the form of, so here Q2 is R. So if you take Q2 as R and this 1 as P, then this complete part becomes Q. So this is in the form of Q plus RP. So this Q2 is R. So here this value should be written as R followed by 1 So as this Q2 is multiplied by 1, it should be written as P, which is added to 1 plus Q3, 1. So we need to take this term as Q. So as this is in the form of R equal to Q plus RP, you need to replace or represent this as R equal to QP star. So Q2 remains as it is, and Q value is 1 plus Q3, 1, and P star. P means this 1. So you will get 1 plus Q3, 1 into 1 star. So we got Q2. Now you can solve Q3. So take the Q3 equation, and in place of Q2, we need to substitute Q2 value, this one. And here this last 0, it remains same. So here you'll get the notation, or you'll get the value like this. And after that, so this is nothing but 1 into 1 star 0 plus Q3 dot 1 into 1 star 0. Again, if you take Q3 common, so here you can see there are two terms with Q3. If you take Q3 common, you will get Q3 into 0 plus 1 1 star 0. And write the remaining part as it is 0 plus 1 1 star 0. So this is in the form of R equal to Q plus RP, right? So this R equal to RP plus Q. Yes. So here you will get R equal to QP star. QP star means this one. 0 plus 1 1 star 0 is Q. P means 0 plus 1 1 1 star 0. That should be whole star, as we have P star here. So this is the final equation.